I have one more example of a piecewise function. And just to show you, I know that they can be really messy. So this piecewise function is 0 when t 0 is less than or equal to t less than pi over 2, and cosine of t when t is greater than or equal to pi over 2. So our Laplace transform, we have to go 0 to pi over 2, 0 e to the negative st dt, plus pi over 2 to infinity cosine t e to the negative st dt. Our first term is just 0, because if we integrate we get a constant, so when you evaluate the endpoints, again that term goes to 0, so I just have to focus on the cosine t e to the negative st. So we're going to have to use parts. And we can't use the nice table method because we don't have any derivatives going to 0. So I'm going to use u as cosine t and dv as e to the negative st dt. So we have to take the derivative of u and we have to integrate dv. Derivative of u, du, is negative sine t dt. Integrating e to the negative st, we get negative 1 over s e to the negative st. So remember, integration by parts is uv minus the integral of v du. So that gives me cosine t times v, which is negative 1 over s e to the negative st, minus the integral of v du. So I get negative 1 over s e to the negative st times negative sine of t dt. So these two negatives cancel each other out. And because this is in terms of t, I can bring that 1 over s out front. So I'm just going to rewrite this a little bit to make it a little cleaner. So I get negative 1 over s cosine t e to the negative st minus 1 over s e to the negative st sine of t dt. So we have to do integration by parts a second time. And you just have to be consistent because I use u as cosine. I'm going to have to use the trig part. So my u is going to be sine of t. And my dv is e to the negative st dt. So take the derivative of u, integrate dv. So du is cosine t, dv is negative 1 over s e to the negative st. So we have to put all this stuff together. So I'm going to start off with the original integral, which was cosine t e to the negative st. When we did integration by parts the first time, this is what we got. So it's negative 1 over s cosine t e to the negative st minus 1 over s. And then I have to plug in what I got the second time. So uv would give me negative 1 over s e to the negative st sine t minus the integral of v du. So that's negative 1 over s cosine t e to the negative st dt. Hope I did not mess up a sign. Alright, distribute all this stuff through. So I get negative 1 over s cosine t e to the negative st When I multiply these together, I get plus 1 over s squared e to the negative st sine t. And when I distribute over here, I get negative 1 over s squared cosine t e to the negative st dt. I'm just checking to see if I messed up anything. I think I'm all set. Alright, so this I need to move over to the other side. So I have to add 1 over s squared cosine t e to the negative st dt here to get rid of that, and then I have to do the same thing on the other side. 1 over s squared cosine t e to the negative st dt. So when you add those two together, you get 1 plus 1 over s squared cosine t e to the negative st dt equals negative 1 over s cosine t e to the negative st plus 1 over s squared e to the negative st sine t. And then lastly, if you put that together, we get s squared plus 1 over s squared. So I'm going to multiply this side by s squared over s squared plus 1. To get rid of that coefficient. And that's what I end up with. Alright, now I have to integrate this because my limits of integration were from infinity to pi over 2. So when I plug in infinity for t, this term here goes to 0. Let me show why that is true. Alright, so when I plug in infinity, my numerator here is fixed, the denominator is blowing up. So at infinity, this term goes to 0. And then here, the same thing, this term goes to 0. When I plug in pi over 2, I get negative cosine pi over 2 se to the s times pi over 2. Well, cosine pi over 2 is 0 plus sine of pi over 2 s squared e to the s times pi over 2. So that term goes to 0. This, we get 1 over s squared e to the pi over 2. So I'm left with negative s squared over s squared plus 1 times 1 over s squared e to the s times pi over 2. So these s squareds cancel, and I'm left with just negative 1 over s squared plus 1 times e to the s times pi over 2. And I hope I didn't mess up a sign because this was a long problem. But you have to know how to do integration by parts. Like this is a Calc 2 problem where you had to do it multiple times. And if I have a chance, I will go back and check this because it's long and I could have easily dropped a sign.